our country and all its people could be in danger of nuclear attack in minutes by enemy missiles, in hours by enemy aircraft. Our cities, our farms, our factories. Prime target would be our air bases. With all our aircraft on the ground, our weapons of interception or retaliation not instantly available, we might face another and infinitely more costly Pearl Harbor. Surprise disaster, some of our aircraft must always be in the sky or on the alert, carrying nuclear weapons. These weapons are always unarmed. They will be armed only following a decision by the President of the United States. Only these ready aircraft with nuclear weapons can form our first-line deterrent force in peacetime. Our sure striking force in case of attack. We, the American people, understand and accept this necessity for our survival. But we want to know the facts about one question. Do we live in danger of nuclear explosion and radioactive fallout if one of these airplanes should crash, or one of these nuclear weapons accidentally drop? To give you the facts, the United States Air Force presents There was no nuclear explosion, no radioactive fallout. These are the facts.
Any explosion is the result of the very rapid release of a great amount of energy. Conventional explosions result from the rearrangement of whole atoms in some explosive material. For example, in TNT, the rearrangement of whole atoms of hydrogen, carbon, nitrogen, and oxygen produces explosive force. On the other hand, nuclear explosions result from the rearrangement within each atom. This may be a joining together or fusion, as in an H-bomb, or the splitting apart or fission, as in an A-bomb. At present, an H-bomb explosion starts with fission. So the splitting of the nucleus of the atom is the basic principle of nuclear weapons. All matter is composed of one or more of the 100-odd elements. Of these, the atoms of the metals uranium and plutonium can be most readily fissioned to cause nuclear explosion. These elements are mildly radioactive. They emit short-range, low-penetration alpha particles while in their unfissioned state. These alpha particles do not have the harmful effects of the longer range and stronger gamma rays, which are given off by certain elements such as radium or by the products of nuclear fission. The atoms of uranium and plutonium are among the heaviest. Heavy because the nucleus of each atom contains large numbers of the fundamental particles called protons and neutrons. When a free neutron hits this nucleus, it splits into two parts, releasing more neutrons which may go on to split other nuclei. The resulting fission products become highly radioactive, emitting the long-range and dangerous gamma ray. The split nucleus weighs less than the full one, and this difference in weight is released in the form of energy, nuclear energy. After fission, harmful gamma radiation. Before fission, innocuous alpha radiation. To build up a nuclear energy release, the fissionable material must be of a certain size, shape, or density. Then one of the neutrons escaping from a split atomic nucleus will, in turn, split another, and a chain reaction is set up. The mass is now releasing nuclear energy, but not quickly enough to cause a nuclear explosion. This condition is called critical. If the mass is now suddenly increased, so that more neutrons are trapped each time an atomic nucleus is split, a multiplying chain reaction is maintained. Now the mass is supercritical, causing a nuclear explosion.